Hello my dear students, welcome to all in Sri Sharda Bhavan Education Society Nanded. Dear students, today we will discuss the paper analysis. Okay, now the question number is 69. Which of the following represent the correct order of decreasing inductive effect? You know very well, the inductive effect is a phenomenon where atom or group of atoms in a molecule pulls or pushes electrons towards or away from itself through a sigma bond. In general, the more electronegative group is the more withdraws electrons negative inductive effect, and the electropositive group is the more it donates the electron. It is known as a positive inductive effect. Now here bond NH3 positive is a strong electron withdrawing group, so having the highest order. Okay, bond NO2 strong electron withdrawing group due to the high electronegativity of nitrogen and oxygen atoms. So in second order NO2 will become, and lastly bromine. So the correct answer of question number 69 is option A is correct. Bond NH3, bond NO2 and bond Br. It is the correct order of decreasing inductive effect. Now question number 70. Here what happens? Arrange the following in the correct order of their stability. Now here you know how to decide the stability of the carbanion. Okay, carbon having negative charge. So here question number 70. To determine the correct order of stability of the given carbanions, we need to consider the hybridization of the carbon atom bearing the negative charge and the extent of S character in the orbital. The more S character in the orbital holding the negative charge, the more stable carbanion. S character जिसका ज़्यादा है वो बंदा स्टेबल ज़्यादा है. Okay, now in the first option here CH triple bond C negative. Okay, the carbon with the negative charge is sp hybridized. Okay, this carbon is sp hybridized and having the S character is 50%. Okay, now second one CH2 double bond CH negative. In this option the carbon with the negative charge is sp2 hybridized with 33% character. And lastly CH3 bond CH2 negative. This carbon atom is sp3 hybridized carbon atom and S character is 25%. So here the stability order is 1 is greater than 2 and 2 is greater than 3. Just simple. Okay, now move towards the question number 71. Which of the following is aromatic? Dear students, this question is very important and such question will be asked in your Neet examination. Okay, now what is aromatic compounds? Okay, to determine the aromatic compounds or to calculate the aromatic compounds, given compound is aromatic or not, how we decide? We need to apply Haeckel's rule. Okay, now here look towards what is Haeckel's rule. Haeckel's rule. Okay, now for aromaticity, according to Haeckel's rule, a compound is aromatic if it is, number one condition, it must be cyclic one, number two, it is planar, number three, having conjugated has continuous p orbitals around the ring, and number four, 4n plus 2 pi electrons. Okay, now here n is the integers. Now what happened? Let's analyze the option. Option number 1, it is the cyclopentadiene cation. It has 4 pi electrons since it's carbon with 4 electrons in the conjugated system, which doesn't fit the 4n plus 2 pi electrons. Now option number 1 does not fit in the Haeckel's rule. Option number B, cyclopentadienyl anion. Okay, first one is the cation, one is the anion. It has how many pi electrons? 2, 4, 6 pi electrons. fits the 4n plus 2 pi rule, where n is the integer and it is a cyclic, it is a planar one. Okay, so option B is the aromatic. Option B is the aromatic. How many pi electrons here? Pi electrons is the 6 pi electrons. So 4n equals to 6 minus 2 equals to 4n equals to 4. So n equals to, it becomes 1. 1 is the integer. So it follows the Huckel's rule. Every carbon atom is sp2 hybrid and follows the Huckel's rule here. So correct answer of this question is option number B. C is a cyclopentadiene. It has a 4 pi electron, doesn't fit the 4n. So this is not your answer. And also D, cyclohexadienyl cation, it does not fit the criteria for being the aromatic, typically due to the not having the required number of pi electrons for the aromatics in a simple analysis. So correct answer of the question number 71 is option B. Now let's move towards the question number 72. The order of the negative effect, inductive effect orbitals in. Now what happens? The correct order of the negative effect, inductive effect for the given hybrid orbitals is based on the electronegativity of the carbon atom in a different hybridizations. The more S character, okay, in the hybrid orbitals, the more electronegativity. Okay, more electronegativity, more electronegativity. Now here in sp orbitals, S character is more than sp2 is more than sp3. Okay, here is 50%, 33% and only 25%. So correct answer of this question option number C. Question number next 73. Consider the given compounds. Okay, now here you decide to give the basicity order here. Okay, the question is incomplete. Here the question is consider the given compounds and arrange there in accordance to the basicity order. To solve this question, we need to consider the basicity of the given compounds. The basicity of the amines here, these are the amines compounds, and is influenced by the availability of the lone pair of on the nitrogen atom for the protonation and in the inductive effect of the groups attached to the nitrogen. Here is the compound number 1. We draw here option 1, that is a CH3 bond to CH2 bond NH2. This is the primary amine known as the ethyl amine. Okay, now B1 is a CH3 bond CH यहाँ पर NH. Okay, now this is the incomplete. Okay, here must be NEH and here CH3, that is a secondary amine. Now C is the CH3 single bond C triple bond N, and D1 is the C2H5 NEH bond C2H5 diethylamine. Now what happens here? Okay, what? Okay, C is the nitriles, here is the diethylamine. Now nitriles, okay, option C here, option C, nitriles are not bases due to the involvement of the nitrogen lone pair in the conjugate with the triple bond. Okay, these are not the basic. Okay, now C will be in the last. Okay, now look towards the option where C is the last, not here, not here, it may be A or it may be C. Now the primary amine. Now my dear student, this primary amine having the lone pair and more basic than imines but less basic than secondary amines due to the inductive effect. So here A will be in the third option, third number. So here option number A will be your correct answer. Okay, now move towards the question number next, question number 74. Give the correct order of increasing acidic strength of the following compounds. Here the question, you want to know the acidic strength of the compounds. Here question number 74 is here To determine the correct order of increasing acidic strength of the given compounds, we need to analyze the nature of the functional groups first and attach to the cyclohexane ring and their influence on the acidity. Identify the compounds one. Here, first compound is your cyclohexanol. Okay, and cyclohexanol, here alcohols are more acidic. The functional group is the bond OH, and alcohols are the more acidic. So number one is more. Look towards the option. Where is the number one is more? Option number C and option number B. Option number A and D is eliminated. Okay, now after cyclohexylamine, option number 2, amines are weak acids due to the basic nature of amino groups. Okay, and now option number 3, cyclohexyl acetylene terminal alkyls are more acidic than alcohols. So the order will be 1 is more than 3 and 3 is more than 2. The correct order of acidic strength will be option number C. Okay, now move towards the question number 75. Arrange the following compounds in basic character. Dear students, here option 1 is your 1 degree amine, option B is your 2 degree amine, and option C is your 3 degree amine. Okay, you know very well the trick to recall the basicity in the amines. Here you must be remember this number 2310. Here the basicity will be secondary amine is more basic than 3 degree amine is more basic than 1 degree amine and 0 degree amine. So correct order and correct answer of this question will be option number B. Okay, very simple question. Now next toward the next question, which cannot show the tautomerism. Tautomerism कौन नहीं बताता है? Question number 76 here. Now to determine which of the given compounds cannot show the tautomerism, let's first understand what is tautomerism is. You know very well tautomerism is a phenomenon in organic chemistry where two or more molecules called tautomers are in equilibrium with each other. And my dear student, this is typically involves in the movement of hydrogen atom and a double bond, which often seen a ketoenol tautomerism. Okay, now look towards the option number 1, cyclohexadiene ONA. Okay, can show tautomerism to form a phenol. Now this move towards the electrons here. Okay, protons here and formation of the here phenol. Okay, phenol compound यहाँ पर बन जाता है, ये tautomerism यहाँ पर शो करता है. Okay, now B complex, the name of the complex is 4,4 dimethyl cyclohexa 2,4 diene. The compound with the two methyl groups on the carbon next to the carbonyl group can show tautomerism, but it might be less favorable due to the steric effect of the stability of the potential tautomer. Here is the steric hindrance, and due to the steric hindrance, option B, this compound does not show the tautomerism. Option C, cyclohexanol can show tautomerism, formation of the phenol, and also formation of phenol. So correct answer is option number B. Okay, let's go towards the question number 77 here. Arrange the following in decreasing order of acidic strength. Dear student, now acidic strength arrange करना है यहाँ पर. To determine the increasing order of acidic strength of the compound, we need to consider the effect of the nitro group on the acidity of the phenol here. Nitro group play an important role here. Okay, to decide the acidity of the compounds here. Compound number 1 is the phenol, no nitro group is present. Okay, now compound number 2, paranitrophenol, nitro group is the para position. Compound 3, beta nitrophenol, nitro group is at the meta positions, and compound 4, orthonitrophenol, nitro group is the at ortho positions. The acidic strength increases with the presence of a nitro group. Here acidic strength acidic strength increases, NO2 group increases here. Okay, ortho and para positions. Okay, this ortho and para position both allow effect withdrawal of electrons through resonance, increasing acidity. Ortho might have an additional effect due to the intramolecular hydrogen bonding. यहाँ पर इंट्रामोलिकुलर हाइड्रोजन बॉन्डिंग की वजह से यहाँ पर जो है एसिडिक कैरेक्टर पे इफेक्ट होता है. नाउ मेटा लेस इफेक्टिव विड्रॉयल ग्रुप्स. ओके, मेटा यहाँ पर लेस इफेक्टिव विड्रॉयल ग्रुप compared to ortho and para due to the lack of resonance stabilization of the phenomenon and peroxide ion directly through the nitro group. So here acidic character सबसे ज्यादा किसका आता है, तो यहाँ पर आ जाएगा पैरा नाइट्रोफिनॉल, सबसे कम आ जाएगा फिनॉल. सो यहाँ पर 2 and 1 कहाँ पर नजर आ रहा है, ऑप्शन सी is the correct answer. Okay, now question number 78. The number of electron present in the valence shell of carbanion bearing negative charge. The question is very simple. Your answer will be 8. How in carbanion with a negative charge on carbon, the carbon atom has a gain on extra electrons to achieve the stable electron configuration, and carbon valence shell normally has 4 electrons in its ground state with the extra electron for the negative charge, and consider it is typically forms the bonds with other atoms using its 4 valence electrons. So it becomes the 8. Now the having the negative charge, the electron must be the 8. Now next question 79. Which among the given acid has the lowest pKa value? Lowest pKa value. The acid with the lowest pKa value among the given option is the strongest acid. Consider the substituents on acetic acid. Okay, now chloroacetic acid formula is Cl CH2COOH is the chloroacetic acid. Bromoacetic acid BrCH2COOH. Nitroacetic acid NO2CH2COOH, and cyanoacetic acid CH2COOH. Okay, the pK values are influenced by the electronegativity and the electron withdrawing nature of the substituents. Generally, nitro group is a strong electron withdrawing group. Nitro group is the strong electron withdrawing group here. Cyano group is also strong electron withdrawing group. Halogens like chlorine and bromine are electron withdrawing but less effective compared to nitro and cyano in terms of stabilization of conjugate base through resonance and inductive effects. Now typically the pK values of these acids are: pK values of chloroacetic acid is near about 2.87, bromoacetic acid 2.90, nitroacetic acid it is a 1.68, and cyanoacetic acid it is a 2.47. Now less pK values, okay, less pK values किसका है, nitroacetic acid. So lowest pK value इसका आ जाएगा nitroacetic acid. Okay, just simple, nitroacetic acid is the correct answer. Next question, acetic acid is considered as a resonance habit. यहाँ पर आपको ऑर्डर निकालना है दोस्तों. ये क्वेश्चन जो है थोड़ा सा यहाँ पर ध्यान दीजिए, आंसर क्या आ सकता है इस क्वेश्चन का. फर्स्ट वन, evaluate the structure of the charge placement and octet rule satisfaction. Octet rule structure 1 has no charge, okay, and satisfy the octet rule for all atoms. Satisfy the octet rules. Second structure has a positive charge on the oxygen atom and a double bond to their oxygen atom. Structure 3 has a negative charge, okay, structure 3 has a negative charge on the oxygen and positive charge on the carbon here, okay, and less favorable due to the charge separation and less electronegative atom having a positive charge. Structure 4 here has a charge but it is less stable compared to structures without charges or with charges or more electronegative atoms in a favorable manner. Now consider the stability based on the electronegativity and charge distributions. Now if we consider the charge distribution here, the correct order must be structure 1 is greater than structure 3 and structure 3 is greater than structure 2 and structure 2 is greater than structure 4. The correct order must be this is. So the correct answer of question number 80 will be option number C. Okay, correct answer of this question is option number C here. Next question, question number 81. In which of the following molecule group present on a ring not involved in a resonance? It is very simple. आपको सीधा पूछा है कि भैया रेजोनेंस स्ट्रक्चर कौन नहीं बताता. यू नो वेरी वेल, एनिलीन जो है रेजोनेंस स्ट्रक्चर यहाँ पर बताता है और हमने क्लासरूम में देखा है कि भैया एनिलीन जो है रेजोनेंस स्ट्रक्चर बताता है, फेनॉल भी बताता है, क्लोरोबेंजीन बताता है. ये जो कॉम्प्लेक्स है ये यहाँ पर बताता नहीं है. सिंपल सी बात है, ऑप्शन बी इसका करेक्ट आंसर आ जाता है. नाउ क्वेश्चन नंबर 82. द करेक्ट ऑर्डर ऑफ द डिक्रीजिंग basic strength of XYZ compound complex. To determine the correct order of the decreasing basic strength of X, Y and Z, let's analyze the structure given below. X is the piperidine, a saturated 6-member ring with an NH group. Okay, this is the X. Y, a lactam, a cyclic amide. This is a cyclic amide with the carbonyl group. Yes, it is a carbonyl group adjacent to the nitrogen atom. It is a Y. And Z, pyridine, an aromatic 6-member ring with a nitrogen. 6-member ring with a nitrogen. Now basicity considerations. Piperidine, that is the X molecule, this is the secondary amide. Okay, this is the your secondary amide in a saturated ring. Secondary amides are generally more basic. This is the more basic. So basic character here must be your X is more. So option number C and option number D eliminated. Lactam, that is the Y. The presence of carbonyl group adjacent to the nitrogen in a lactam significantly reduces the basicity. Of the nitrogen due to the delocalization of the nitrogen and the lone pair of the carbonyl. So your second one is the Y and here is the last. So the order must be X is greater than Y and Y is greater than. Okay. So here the order, यहाँ पर y जो है लास्ट में आता है. X is greater than Z and Z is greater than Y due to the presence of carbonyl group adjacent to nitrogen. This complex order in the last. Okay. Now question number 83 again, aromatic character. Which shows the aromatic character? To determine which of the structures shows the aromatic character, we need to apply the criteria of the aromaticity. A compound is considered to aromatic if it meets the conditions of Haeckel's rule, that is the molecule must be cyclic, the molecule must be planar, okay, and it follows the 4n plus 2 pi electrons. Okay, let's analyze the option here. Option number 1 here, this is a cyclopentadienyl radical with a dot indicating, consider the unpaired electrons and the 2 double bonds here, which does not fit the 4n plus 2 pi electrons, so it is not aromatic. B, the presence of 6 pi electrons making it aromatic. Okay, here 2, 4, 6. The correct answer of this question is option number B here. Okay, question number next 84. Which of the following represents the correct order of stability of the given carbocations? Carbocations stability. Benzyl carbocation. Okay, option number 1. Benzyl carbocation stabilize the resonance with the benzene ring. Okay. Second one, cyclopentadienyl carbocation anti-aromatic 4n electrons, making it unstable. Second one is the unstable. Third one is the troponium ion C7S7 positive aromatic 6 5 electrons, highly stable due to the resonance. स्टेबिलिटी की अगर बात करते हैं तो ट्रोपोलियन आयन इज वेरी स्टेबल ड्यू टू द एरोमेटिसिटी. ट्रोपोलियन आयन इज वेरी स्टेबल ड्यू टू द एरोमेटिसिटी. ऑप्शन 1, बेंजील कार्बोकेशन इज स्टेबल ड्यू टू द रेजोनेंस and cyclopentadienyl carbocation is unstable due to the anti-aromaticity. So according to the aromaticity, stabilization will be occur. So option number 1 is your correct answer. A is correct. Okay, question number 85. Which of the following is anti-aromatic species? Anti-aromatic species. So how to determine the anti-aromatic species? Let's analyze the option here. Option 1, the structure show is a pyridine radical. Pyridine itself is aromatic with 6 pi electrons, including the lone pair on nitrogen is the pi system. It does not correct the lone pairs in the sp2 hybridization here. So here is the radical completing the direct clarifications without the considering the number of pi electrons properly here. If we looks toward the option D here, the structure is a cyclopentadienyl cation. This is has a 4 pi electrons, okay, and is cyclic planar and conjugated here. Okay, 4n plus 2 pi electrons 4, so 4n equals to 4 minus 2, 4n equals to 2, so n equals to, it becomes 1. So this complex is यहाँ पर क्या आ जाएगा? It is the anti-aromatic, not 4n equals to 2, so n equals to here 2 by 4. Okay, 1 by 2. Okay, 1 by 2. Now it becomes 1 by 2 here. So option D is your anti-aromatic, because n is integer and it 0 1 2 3 4 5 6, so here it is becomes the 1 by 2, so it does not follow the, that is the rule of aromaticity. So it is an anti-aromatic, it is aromatic and this is an anti-aromatic. So let's move to the question number 86. The order of acidic strength of the hydrogen atom H alpha, H beta, H gamma in the given molecule here. Okay, here this complex stability of alpha hydrogen, beta hydrogen and gamma hydrogen. Okay, now factors affecting the acidic character. First we learn about the acidic character. Acidic strength of hydrogen atom in an organic molecule is influenced by the stability of the conjugated base formed after the removal of the hydrogen. More stable conjugate base corresponding to more acidic character. Given options, the molecule given is, the hydrogens in the questions are gamma, beta and alpha attached to the carbon adjacent to the carbonyl groups. Okay, adjacent to these carbonyl groups here. Here hydrogens on the carbon adjacent to the carbonyl, alpha hydrogens to the carbonyl are more acidic. Alpha hydrogen atoms are more acidic due to the stabilization of the enolate ion. Stabilization of the enolate ion. Now gamma is between the two carbonyl. Gamma hydrogen atom is present between the two carbonyl, making its conjugate base more stable due to the resonance with the carbonyl. So gamma hydrogens are the more stable than alpha and then beta. So your answer will be option number 1 is here. Question number 87. Arrange the following acid in decreasing order of their acidic strength here. Okay. Question number 87. Recall the factors affecting the acidic strength of alcohols. The acidic strength of alcohols influences by the stability of the conjugate base. Alkoxide ions more stable conjugate base corresponding to the strong acid. The stability of the conjugate base is affected by the inductive effect or of alkyl groups here. Compare the acidic strength based on the structure here. Primary alcohols are more acidic. Okay, now you know very well here the primary alcohol is methyl alcohol. Primary alcohols 1 degree alcohols are more stable. So here in option 1 degree is more A naught D naught, it may be B or it may be C here. Okay, now the order of acidic strength is primary is more than secondary. So here where is the secondary alcohol? Here in option number 2. This is not your secondary alcohol. Here the printing mistake will be occur here. It must be the secondary alcohol here. Okay, now this is your 3 degree alcohol and it is your primary alcohol. Okay, option 1 is your primary alcohol, option 4 is your 3 degree alcohol, it is also your primary alcohol and it is also the here is option 3 is your secondary alcohol. Here is your secondary alcohols. Okay, here is your secondary alcohols. Now what happens to determine the alcohol's acidic character? Primary, secondary. Okay, here is your also primary alcohol. Option second one is your primary alcohols. This is your primary alcohols. Okay, 3 degree alcohols and CH3 CH3 it is your tertiary alcohol. So correct option is primary alcohol is more stable. These two are the primary alcohols. Okay, let's I explain in detail here. Primary alcohols are more stable. Okay, primary alcohols are more stable than secondary alcohols than 3 degree alcohols. Here 1 and 2 are the primary alcohols, so order becomes 1 is greater than 2. Okay, now secondary alcohols here option 3 and option 4. So correct answer is option B. Question number 88. Correct decreasing order of pKb. To determine the correct it is decreasing order of pKb for the given compounds, we need to understand how the substituents on the benzene ring affect the basicity of the amines group. pKb is a measure of the basicity of the base. Lower pKb values indicate the strong base. pKb value lower, that is it is the strong base. That is a strong base. Okay, now let's analyze the compound benzyl amine C6H5CH2NH2 option 1. Here the amine is not directly attached to the benzene ring. Amine directly not attached to the benzene ring, so there less effect on basicity from the ring. So option 1 becomes appear in the last. So here 1 A, C and D cancel. Here option B will be the correct answer. Okay, aniline is a basicity is reduced due to the delocalization of the lone pair. यहाँ पर delocalization होता है lone pair of electron. So correct order will be option 4, 3, 2, 1. Order is correct. Okay, question 89. Which among this can exhibit tautomerism? टॉटोमेरिज्म कौन शो करता है भैया? टॉटोमेरिज्म कौन यहाँ पर बताता है? नाउ व्हाट हैपेंस हियर? टॉटोमेरिज्म is a phenomenon where two molecules called tautomers interconvert through the moment of a group or atom, usually hydrogen, often accompanied by the switch of double bonds. For a compound to exhibit tautomerism, it is typically needs to have the hydrogen atom adjacent to the carbonyl group. Here is keynote here. Keynote, what is here? Interconvert through a moment of a group of atom, often accompanied for a compound exhibit tautomerism, typically needs to have hydrogen atom adjacent to carbonyl group here. Now these conditions show the tautomerism here. Okay, now here adjacent hydrogen atoms, option A shows the tautomerism. Okay, here due to the does not have typical structure simple tautomerism like ketone, because the nitrogen is a part of amide like structure. There is an amide like structure, so it does not form the tautomerism. 3 has aldehydes with option 3 ketone. Okay, here is the ketone. Now here is the alpha hydrogen atoms and it shows the tautomerism. So A and third, 1 and third shows the tautomerism. It is not aldehyde, it is a ketone. C double bond O is here. Okay, 1 and third. So option D is your correct answer. And the last question of the question paper is, which of the following group has maximum hyperconjugation effect but minimum inductive effect? Hyperconjugation effect is a maximum when there are more alpha hydrogens. Or in this context CH bonds adjacent to the group. Okay, hyperconjugations. The tertiary butyl group has 9 alpha hydrogen atoms. Tertiary butyl groups, this option. Tertiary butyl group CH3. Tertiary butyl group has 9 alpha hydrogen, maximum hyperconjugations. So here answer must be your option number D, hyperconjugations. Your answer must be D. This shows the maximum hyperconjugations but minimum inductive effect. Okay, my dear students, this is your today's questions of 11th science G3 Neet chemistry paper analysis and discussions. Today's paper based on the pure concept of inductive effect, mesomeric effect, aromatic compounds and aromatic compounds, basic character, acidic character, pKb values. Okay, now we will discuss the more questions in the next lecture. Thank you so much, my dear students, and happy learning.